Guys, stack crystal over already.
Oh my god. Yay!
Wow, celebration for you. 我 left out 的，你们要叫披萨。
Okay,
要叫
stay.
Cindy 啦 ，Go！ 你们要叫什么先？叫这个啊，这个。OK 啦，这个啦，这个我们走了。哇，很饿了嘞。
Wow, hope it faster come in.
诶，我帮你问。OK 啦。
2,000 years later. One eternity later.
Hey guys, why is the pizza so long? I don't know, wow. Now what time already? It's absurd, yeah, for me to wait past 2 hours and still not here. I don't get how you get it done. Just get it here. I don't care.
I'm not the delivery rider.
I don't care. Hey, where? Block 100, 1000, 150. Wow, what are you doing? Where is this now? Oh, you gotta be kidding me. Yes, manager.
Hello, am I speaking to Jared?
Yes, what's up?
Hey, I received a complaint from a customer right, for the English delivery.
Huh?
Where the hell are you?
Hey, I'm sorry lah. I'm at block 1000. But where am I supposed to go? He said for block 1000 also.
I don't get your reason.
Huh? What? Then what?
Give the pizza to them.
But I don't know where it is. Hello? Oh, I hate my life. Oh, no wonder it's block 1000.00. No wonder why I got lost. Ah, this is it. Hello, pizza.
So you're the delivery guy?
Yeah, I am the
Okay, what
delivery.
time is it now? It's 7:30. I ordered at 5 o'clock by the way.
Oh, but no, my problem. The kitchen very busy, right?
When I ordered pizza for what? Look at my friend. All sleeping already. No mood to eat
Hey,
already.
brother, PIE got traffic jam.
But you're the delivery driver, you should know how to plan your work.
Then you block 1000 unit.
It's not my fault, I'm the customer. Customer is always right, maybe how they say.
Ah, but you put decimal place. Why?
How is it my fault? You're the delivery
Yeah,
driver.
but I
You should know
got
this
from
to
you,
me. I'm giving 1 star by the way. I thought you lose your job, seriously. Can I say that?
That seems like a problem. It is natural for customers to feel angry if their orders get delayed. Before we start analyzing any data, we first have to collect data. For this project, we have collected a total of 30 responses. They are independently and identically distributed, which satisfy the IID criteria. Since the sample size is 30, it will follow a normal distribution based on the central limit theorem. We have chosen customer rating as a dependent variable, preparation, delivery time, as well as peak period as our independent variable. Now, let me explain to you more about our independent variable. For preparation, it involves the cooking and packaging process of the pizza. As for the delivery time, it is the time when the pizza is picked up by the delivery man to the time the customer receives their pizza. For peak period, it depends on whether or not the customer placed their orders during busy hours or not. Do note that our timings are all in minutes and the customer rating is from a scale of 1 to 5 stars.
Hi guys, so now we'll be talking about linear regression model. These are our independent variables as identified. Preparation time, delivery time, and peak period. Preparation and delivery time are both continuous variables. What does this mean? For every 1 minute increase in such timings, the customer satisfaction rating will drop as follows. Peak period is a categorical variable, which means that it has assumed of a value of 0 to 1. So if it's 1, it will drop like this. 1 means that there is a peak period. Look at our multiple R-squared and adjusted R-squared values will also indicate that our data is very precise and reliable, as well as these variables being a good prediction of customer rating. So now we'll take a look at the p-values. You'll notice that preparation and delivery time both are very small, which indicates that they are both very statistically significant to customer rating. And therefore, we will want to zoom in on preparation time and delivery time for further analysis.
We'll be using hypothesis testing to see whether we'll reject H0 based on the significance level of 5%. For H0, it means that the total mean waiting time for the pizza to arrive is less than or equal to 40 minutes, inclusive of preparatory and delivery time. For H1, it means that the total mean waiting time for the pizza to arrive is more than 40 minutes, inclusive of preparatory and delivery time as well. From the information extracted from our database, we actually found out the sample mean and the sample standard deviation is as follows. And because we do not have a population standard deviation, we can only use the t-value method and get our beautiful value here. And because we know that this is a right tilde test, and in order to calculate the p-value, we must take 1 minus pt and get this very, very small number. And this very, very small number is smaller than our 0.05. And with that, we can conclude that we will reject H0 as there's sufficient evidence to suggest that 5% significance level that the total mean waiting time for the pizza to arrive is more than 40 minutes.
Now I'll be presenting on the proposed solution. It consists of assigning a food truck and selectively dispatching teams to each neighborhood. For example, one delivery truck can be allocated to block 100 to 500, while another takes block 500 to 900. As a whole, this initiative can save a lot of delivery time as delivery workers are selectively placed in a much more familiar environment. This reduces delays and confusion from navigating around less familiar surroundings. As such, they are less likely to seek assistance for directions, and customers are able to receive their orders timely with satisfaction. After assessing the feasibility of our proposed solution, we have identified three main areas of concern. Firstly, there will be a higher induced running costs, such as petrol and parking expenses, and qualifying for additional hygiene certifications for the food truck. Next, it's likely there will be a high job turnover. There will be a need to retain current staff or hire new staff to familiarize the employees with the job scope. Lastly, there will be an increase in manpower. Although there will be an increase in cost from higher manpower, this means that there are a lot of new job opportunities for expanding on the services provided.
Hey, wow, so nice eh? Can cook on the go. Then my friend say, wow, very fast to prepare food now because so many orders. Okay, guys, here, block 122, block 100. Been here millions of times.
Yes. Yeah. Oh my gosh. It's so fast now. Yeah, so efficient. Wow, I'm so familiar with this place. I know exactly where to go. Pizza delivery!
Wow, you're so on time, even earlier than my friends. I'm going to give you a tip, okay? And then I'm going to give 5 stars also.
Thank you.
Yeah, here you go. So much better than Gerald.
So with our newly implemented solution, one might wonder, will our solution actually work? To prove that, we'll do a second round of hypothesis testing. So our solution is to aim at reducing our preparation time as well as delivery time. So assuming that we reduce our preparation time by 1.5 minutes, as well as the delivery by 2.5 minutes, we come up with our new sample mean. So same as the first round of hypothesis testing, we will do at 5% significant level, and holding our SD being unchanged. So for the t-value, using the same formula, this will be our new t-value, these sexy numbers. So once we have our t-value, we move on to the p-value. This is a right tail graph. We will use the function of 1 minus pt, and this will be the new p-value of the second round of hypothesis testings. These sexy numbers. Okay, so back to the graph. This will be our rejection area, and this will be our p-value rejection area. So as seen, since p is more than 0.05, we do not reject h0, as there is sufficient evidence at 5% significant level to show that the total mean waiting time for our pizza to come is less than 40 minutes.
Fast delivery, happy customer, happy worker!